Okay, just to save some time, I'm gonna skip over this top part here. But ultimately, goal for today is we're using trig or trig ratios to find missing side lengths of right triangles. Tomorrow we'll be using trig ratios to find missing angles of right triangles. So you'll see both ways. Tomorrow is going to be using inverse trig. But on your calculators, not that you need these keys today. You don't need them today. But you've probably seen or even used the sine, cosine, tangent keys. And depending on which calculator you have, they might be in a different spot. So tomorrow, we'll definitely be using those more. I'm not sure if we need that today. But talking about trigonometry. So trigonometry, that word, it comes from two Greek terms. Trigon, which means triangle. And then metron, which means measure. All right, trigonometry is really like its own subject in math as well. There's algebra, there's geometry. Algebra 2 is still algebra. And then there's trigonometry. We have the class trig/pre-calc, but trigonometry is like its own study. So trigonometry is really centered around measurements of triangles. There's other things involved, but that's why we're studying it within geometry. So the study of trigonometry involves, like I just said, triangle measurement. And then what we have are trigonometric ratios. You can abbreviate that as trig ratios. And it's a ratio is a fraction, of the lengths of two sides of a right triangle. And this is important too. This only applies, just like Pythagorean theorem only applies to right triangles. These trig ratios only apply to right triangles. So for right triangles only, these are the three most common trig ratios. Sine, which is abbreviated SIN, so it's not sin. Cosine, COS, it's not cos, it's cosine. And then tangent is abbreviated TAN, so it's not tan. So I do want you to make sure you're using those terms, sine, cosine, tangent, and not saying tan of B. It's tangent, even if you see TAN. And then these all focus around the hypotenuse of a right triangle and then whatever is considered the opposite and the adjacent side. So we're going to write the ratios. We're going to start out for angle A. So if we look at this, angle C is our right angle. So if we look at angle A here, bless you. So I'm going to label C as the hypotenuse. What did we say in chapter 1? What does the word adjacent mean? Next to. So the adjacent side is the side that is next to the angle that is not the hypotenuse. So there's only two sides next to angle A. One of them is the hypotenuse, the other one is the adjacent side. So side B would be the adjacent. And then the side opposite is the side across, the side that doesn't touch the angle. So side little a is the opposite side, which I'm just going to abbreviate OPP. So I'm going to go across for all of these. Sine is the ratio opposite over hypotenuse. So for this triangle, it would be A over C. Sine of A is A over C. Cosine is the adjacent side over the hypotenuse. So for angle A, that would be B over C. And then tangent is the opposite side over the adjacent side. So for angle A, that would be A over B. Okay, and now I'm going to use a different color for angle B, because notice that was sine of angle A, cosine of angle A, tangent of angle A. If I change the angle to angle B, my hypotenuse is still C, but my adjacent and opposite now switch. because side A is next to angle B. So this is now the adjacent side for angle B. And then side little b is the opposite of angle B. Okay, so what happens is for sine of angle B, we have opposite over hypotenuse. So that's B over C. For cosine of angle B, that's adjacent over hypotenuse, so A over C. And then for tangent of B, it's opposite over adjacent, so B over A. So it depends on which angle you're referring to. And you're only in a problem, usually you're going to be referring to one angle. Some examples on here I have multiple just to get that down, but it's important. What I usually do is I label the angle and I label what's the hypotenuse, what's the opposite, what's the adjacent. There is a mnemonic device to remember the trig ratios because I do not give these to you. The mnemonic device is SOHCAHTOA. So I'm going to write it two different ways. One way is just to write it like this, but I kind of like to write it this way. Okay, SOHCAHTOA, if you can remember that. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you, I like to write it this way because then it shows you the ratios there. But you have to remember what the letters stand for. But that's a way to remember what those three trig ratios are. Okay, are there questions so far on those? We're going to use them. The questions so far on those. Okay. The trig ratios are found from the acute angles of a right triangle. You cannot find trig ratios of the right angles. So notice we did not label what is sine of angle C, cosine of angle C, tangent of angle C, because that is your 90-degree angle. We only did it for angles A and B, the two angles that would be less than 90. So you'll never use a trig ratio for the 90-degree angle, only for the acute angles. Okay. So if we look at this first set of examples, this first triangle, first of all, in this triangle, angles P and Q are what type of angles? Acute. So we can find the three trig ratios for them. I'm going to start out with angle P. So we have sine of angle P, cosine of angle P, tangent of angle P. I'm going to label angle P here. What side of my triangle is the hypotenuse? 17. And then for angle P, which side is the opposite side? 15 is the opposite. 8 is the adjacent. Okay, so I'm going to look at SOHCAHTOA. Sine of P is going to be opposite over hypotenuse. So that is 15 over 17. Cosine of P is adjacent over hypotenuse. So that would be 8 over 17. And then tangent of P is opposite over adjacent. So that is 15 over 8. Okay, so those are the fractions, and then decimals you would just divide those fractions. So you don't actually need to use the sine, cosine, tangent keys. So you would do like 15 divided by 17. Ooh, there's a glare. So this is approximately 0.88. And then for 8 divided by 17, that's approximately 0.47. And for tangent, 15 divided by 8 is exactly, so this one I'm just going to keep, 1.875. There's only 3 decimal places. I don't need to round it. Okay, so that's for angle P, bless you. If we now change to angle Q, 17 is still your hypotenuse, but again, your opposite and your adjacent will now switch because the side opposite Q is 8, the side adjacent to Q is the 15. Okay, so sine of Q will be what as a fraction? 8 over 17. Opposite over hypotenuse. What will cosine of Q be? (15/17) adjacent over hypotenuse. And then tangent of Q, 8/15, opposite over adjacent. Okay, I'm just going to write the fractions for those. You do actually, oh, you don't have all of them, but getting the decimal, you would just divide the fractions. And usually, I like to leave them as a fraction anyway, unless it specifically asks you for a decimal. Questions on those? Okay. I'm going to kind of skip around here because I do want to make sure I leave time for you to work. So 7, same type of problem, just a different triangle. So I'm going to skip over 7 for right now. Example 8, it says find the tangent of 30 degrees. And notice we're given a 30, 60, 90 triangle with those formulas for the side lengths written. But if I'm going to find tangent of 30, so when I think SOHCAHTOA, I'm using TOA, so opposite over adjacent. Here's my 30, and this is how I'm going to set it up. So it's always tangent, so TAN, of your angle. So my angle is 30 degrees, so tangent of 30 degrees equals, and then opposite over adjacent. So what side is opposite the 30? The x. So it'd be x over, what side is the adjacent? X square root 3. So x over x square root 3. And then this, we didn't have to do this on the front, but fractions you should always simplify. So we should simplify this. These x's will cancel out. It's kind of like having 2/2. So these will cancel to both be 1s. So I'll have a 1 on the top. This would be 1 square root 3. You don't really need the 1 there. So I really have 1 over the square root of 3, but that is still not simplified because I have a square root in the bottom. So what do I have to do? Yeah, multiply by square root of 3, top and bottom. So I get square root of 3 on the top. If you have the 1 in front, that's fine. And then square root of 3 times square root of 3 is 3. Okay, so tangent of 30 degrees is square root of 3 over 3. These x's canceled out. It was like when you have something over itself, they both cancel to be 1s. So this became a 1 here as well. Any other questions on that one? Okay. Again, I want to leave time to work. I'm going to skip over 9 because that's similar. It was having you sketch a 45, 45, 90. So it's just another special right triangle, so similar example. But I do want to look at 10 because this one is a little bit different. And I guess you do actually need the sign for some of these. So 10 says a certain part of a hiking trail slopes upward about 5 degrees. So you see this triangle, I know the picture looks kind of dark, but this angle right here is 5 degrees, it's labeled. After traveling a horizontal distance of 100 feet along this part of the trail, what would be the change in a hiker's vertical position? And notice on the triangle, the vertical height here, and it might be cut off on your sheet, it is labeled X. So we are trying to find X in this case. So let me actually redraw this triangle, just because that picture is so dark and there's a lot of stuff drawn on it. So that's X, that's 100. This is 5 degrees. And then we have Y up here. Okay, so we are trying to find X in this first part. So I am going to use the acute angle that I'm given. I'm given the 5-degree angle. So I'm going to use the 5-degree angle. Here's where you have to determine a trig function to use. You're setting up a trig equation. So I'm also going to write off to the side my SOHCAHTOA so we can determine what to use. So I definitely want to use the side that I'm given an actual value for, which is the 100. So in relation to the 5 degrees, is the 100 the opposite, adjacent, or hypotenuse? The adjacent. Okay, so I'm going to use the 100. And then since I'm trying to find X, I'm going to use the X. And is X the opposite or the hypotenuse? Opposite. So now if I look at my 3 trig ratios, if I have the adjacent and the opposite, which ratio do I need to use? The TOA. I need to use the tangent because I have opposite and adjacent. I don't have the hypotenuse. Sine and cosine both need the hypotenuse. So here's how I'm going to set it up. Tangent, so TAN of my angle, so tangent of 5 degrees, is equal to opposite over adjacent, so X over 100. Okay, so I set up an equation using a trig ratio. Now I have to solve this for X. So if you were to solve this equation for X, get the X alone over here, what would you have to do to both sides? Multiply by 100, yes, on both sides. Okay, so I would get X is equal to, now this, you can type in your calculator. Okay, and since, again, like I said, I want to leave some time, so I'll just go through one other example, but when you type this in, I can type it in exactly like this. I can type in 100 times tangent of 5. So notice when I hit tangent, a parentheses comes up, and you're putting the angle measure in that parentheses, and then I hit enter, and I can round to a couple decimal places, so X is approximately 8.75. Okay, and if you have trouble typing that into your calculator, please let me know. But it would be approximately, if I switch this around, 8.75, and that's measured in feet. So that is the vertical position. Mm-hmm.
I don't know if it's my calculator, but I typed in something and I got like a way different answer that is not.
Okay, I'll look at yours to make sure your calculator's in the right mode also. So notice if you have a calculator like mine, it should say DEG. That means that you're in degree mode. So I can look at yours because there is another mode. There's radian mode, and if it's in that mode, you would get a different answer. Oh. When you all, do you all have different calculators than mine? Yeah, okay. So I'll check and make sure that it's in the right mode. So just hold tight. I'll check that. Then second part of this question, it says, what is the distance that the hiker traveled? So on this triangle, because notice you have X and you have Y, the hiker is actually traveling the trail is that hypotenuse, the Y. So here we're trying to find y. And y is the hypotenuse here. So we're going to set up another trig equation, but I'm not using the opposite anymore. I found x, but I'm not plugging that in. I'm still using the side I was given with the side I need to find and my 5-degree angle. So if I have the adjacent and the hypotenuse, which trig function should I use? Cosine. Yep, the C, adjacent over hypotenuse here. So I'm going to set this up as cosine, COS, of 5 degrees is equal to, and it's adjacent over hypotenuse, so that is 100 over y. And I have to solve for y. Now this is a little trickier when the variable is on the bottom. My first step, just like we multiplied here by 100 because it was the denominator, my first step is to multiply both sides by y so that it's not in the denominator. Okay, but there's another step I have to do. So if I were to write this right now, I have y times, I'm going to keep this as cosine of 5 degrees is equal to 100. Sorry, sometimes my 5s look like s's. So cosine of 5 degrees. Cosine of 5 degrees is just a number. So because it's being multiplied by y, then I can divide both sides by that. Okay, so when I'm finding y, this is what I type into my calculator. I type in 100 divided by cosine of 5. And again, when I hit cosine, the 5, I need to make sure goes in the parentheses because that's my angle. Hit enter. So y is approximately 100.38. And that's also measured in feet. Okay, and then I'm going to pass out the assignment, but 11, 12, 13, so these are similar to 10. I know I was skipping over examples that were kind of similar, where you have to figure out, you have your angle, and then you figure out what the sides are in relation to the angle to know which trig equation to set up. Okay, so you'll have some practice with that. Are there questions on this?